Welcome back, everybody. This is Carter Engineering and Fabrication. I'm Chad. This is week 6 of 2025. I'm trying to get a video out every week documenting what progress I make, whether it's a lot or in this case, not quite a lot. I had a shorter day on Friday than I would have liked, but got some cool work done on the Langmuir MR1 milling machine, making some updates to the machine itself, and then some brake brackets for the Camaro 8.8 rear end. Also have some cool Solidworks stuff to share this week, so let's just jump right into it. Jumping right into it. So this machine hasn't been used in a while, so my initial startup is just scrubbing down some of the chips and correcting an issue that's been lingering for a while, and that's the auger system that I added. It's kind of a homebrew. Not kind of. It is a homebrew auger. It's a 2-inch post hole digger that I've cut down, added to a eBay gear motor with some laser cut bits and a 3D printed gear system. Jumping to the lathe and then making up a space here. Basically all I'm doing is I took the chisel point tip off of the 2-inch auger and then turned an extension. Here I am pounding that extension into the collar and then pounding that into the auger itself. So getting the auger into the end of the chute assembly. Here I am propping it up on the weld table, just doing a quick and dirty, hand-powered rotary MIG weld. It's not pretty, but just trying to get back to the real stuff. So jumping forward a little bit, getting it in the machine, and getting it reassembled. Skipping through a little bit here to putting the side panels back in. The machine's been vacuumed out, cleaned, and trying to just get it reset for some actual production work. And I'm going to jump in just a second to the actual video. So here's the reversible motor running in the feed direction. You see the auger. It's in a 3-inch channel and it's a 2-inch auger. I'd like to correct some of that, but here's the gear motor with the 3D printed gearing. I figure that's the fuse in the system. Yeah. So just a brief refresher on what we're looking at. We are working on the Camaro Ford 8.8 rear axle. Specifically now the brake bracketry. So looking here at the wings, which were laser cut, and then today we're going to be focusing on the center machined adapter hat, let's call it. So here it is, pulled up in Fusion, spinning it around a little bit, and the goal is to just start machining the blanks out of 6-inch round 6061 material, 6061 aluminum material. So you see a adaptive tool path, leaving some clearance in the center for a center stud to just single bolt it to the table. The cutting forces are very low, and it's a 5/8 all thread that I just pinned it to the table with. So here I am going through the simulation just to show. It's a 1/2-inch 3-flute end mill, cooling on. I think I did a pretty fine, like a 12th thou step down, just to get some of that curvature in place and have a nice looking part. So this is the first op, and then the second op for the bolt pattern. After this it gets a lot easier because it's got 2 flat faces that will interface with the standard jaws. So for right now I'm clamping it to the actual machine base. Here I am on the Bridgeport just doing some manual prep on the blanks, basically just punching out a center hole and chewing through that pretty easily. If you look really closely, you can see my arcade controls for the VFD. I have a thing for arcade buttons in industrial settings. So here we are back over at the Langmuir MR1, getting it prepped, getting the blanks bolted to the table. Everything, I'll speed this up significantly, but here I am bringing you in a little closer just to see the blank bolted to the table. That pass-through is coming in extremely handy to have a larger bolting. I'll spare you the hour of machining, but Bringing you in here just to show, I think I've skipped ahead quite a bit. Now I'm on the second op with the bolt pattern, boring that in with a 1/4 inch end mill. Yeah, I'm really liking this machine the more and more I use it. Here I am, just a quick time lapse showing the screensaver, shows you how much time is passing, and then again jumping ahead in time, 2 brackets roughed out, and then the laser cut brackets that came in from Sencut Send, and oop, look at that, brand new dead plug. Okay, we're recording on you, the screen, and mic, so let's go through this again. So we're looking at the SolidWorks assembly for the Ford 8.8. You guys are probably getting a little tired of looking at it. I know I am at this point. So this is one of the struggles with bringing in 3D scan data, so raw data, in this case output from the RevoPoint Morocco. RevoPoint, anyway, not important. The ideal case for me at least is that I want to see shaded with edges on all of my modeled components. However, I don't want to see edges on anything with mesh data. And it just, I have a really powerful PC, thanks Rob, but this is, it's a huge drain on resources. And even like SolidWorks will prompt you to turn off edges on big assemblies and things. The ideal case is that you would change the mesh to shaded, no edges, and then have everything else be shaded with edges. And I've finally figured out a way to do that. The problem is that the typical override is with display states, where you go into the graphics body in this expanded menu in the feature tree, and you'd right click and change it to shaded without edges. That option isn't there for graphics bodies, so you have to do the opposite. We have to go in and change it to shaded without edges everywhere, and then for all of the solids we come in and we say shaded with edges. And if I recalculate you, there we go. So the display state in the feature tree for all of the, in this case, 42 solids or whatever it is, they are overridden with shaded with edges. So this is excellent. It's a much better use of resources. I'm using the 3D scan as a reference. I could still turn edges on if I wanted to reach in and grab some points to like best fit a plane or something, but this is extremely helpful. I'm going to jump into another assembly and just show, again, I have the rotor with edges, I have the brake caliper brackets, the laser cut pieces from Sencut Send, as well as the main, main bracket shown with edges here, and the scan data as just shaded. So a nice tidbit that probably helps somebody out, especially as 3D scanning gets more prevalent. And yeah, back to the regular scheduled stuff. So those of you that watched the last video, I ran short on the pallet racking mesh panels, but I was able to get what you see here picked up for a really good price, and with a little creative cutting to get them to fit the correct dimension, that's going to work out really, really well. All right, so I saved these 3 aluminum light boxes. They were for overhead lights in a parking lot, but I've been saving them. They're about 2 foot by 2 foot by 1 foot deep, and it hit me what I should do with them, and that's a Buick Olds Pontiac sign. So I'm teasing this just a little bit. I'll go into the details, but basically a mixture of acrylic and aluminum. I'm going to make a set of lighted LED sign boxes, a BOP dealership style sign, with 1970 era logos. All right, guys. So it's about 11:30 Sunday night. I'm trying to wrap this up and get it edited. So I'm rushing through it a little bit, but if there's anything you guys want to see, please leave a comment. I'll expand on any topic. I'll nerd out as hard as you guys want, but I'm trying to keep these videos short and just kind keep myself motivated to get work done and share what I'm working on. This is more for me than anything at this point, but we're just bringing you guys along for the ride, and let's see where this goes. So drop a comment, message me. I think I know all 12 of my subscribers at this point, but yeah, that's it for this week. So I'll see you guys next week. See you.